Burner sir, this is a presentation video of my group. The topic is Coordinate System and Transformation. Coordinate System and Transformation. The procedure for converting from one coordinate system to another is known as coordinate transformation. The procedure requires that some points have their coordinates known or measured in both the arbitrary and the final coordinate system. Such points are called control points. A coordinate system is a mathematical framework used to represent points in space. It provides a systematic way of assigning numeral values called coordinates to each point in a space. Coordinate system are commonly used in various fields including mathematics, physics, computer graphics, and navigation. There are several types of coordinate system, but the most common ones are Cartesian coordinate system, also known as the rectangular coordinate system. It uses 2 or 3 perpendicular axes, x, y, and sometimes z, to present points in a space. Each point is uniquely identified by its coordinates x, y, and z, which represents the distance along each axis. Number 2 ay popular coordinate system. It uses a radial distance r and angle 0 to present points in a plane. The radial distance represents the distance from the origin and the angle presents the directions from reference axis. Number 3 ay cylindrical coordinate system. It extends the polar coordinate system by adding a vertical axis, usually denoted as z. It represents points in 3-dimensional space using the radial distance, the angle 0, and the height z from reference plane. Number 4 ay spherical coordinate system. It represents points in 3-dimensional space using the radial distance p, the inclination angle 0, and the azimuth angle 0. The radial distance is the distance from the origin. The inclination angle represents the angle from the positive z-axis, and the azimuth angle represents the angle from the positive x-axis in the xy plane. Coordinate transformation involves converting coordinates from one coordinate system to another. This is often necessary when working with different coordinate system or when transitioning between represents of the same space. The transformation process typically involves a set of equations or algorithms that relate the coordinates in the original system to the coordinates in the target system. Graphic libraries. There are 2 types of graphic libraries: hardware-dependent program and hardware-independent program. Hardware-dependent program, dito pumapaloob ang application program, driver, input, output devices. Ang hardware-dependent program naman ay application program, graphic library, driver, input, output devices. There are example of graphic libraries. Ang una ay Core, GKS, Specs, OpenGL. Coordinate system. Coordinate system identifies location on the display. Virtual device coordinate system. Usually, the origin is at the low left corner and UV range from 0 to 1. There are 3 types of coordinate system. Ang number 1 ay Model Coordinate System or MCS. Identifies the shapes of object and it is attached to the object. Therefore, the MCS moves with the object in the WCS. Number 2 ay Word Coordinate System or WCS. Identities location of objects in the word in application. Number 3 ay Viewing Coordinate System or BCS defined by viewpoint and view site. Coordinate system, viewpoint, and view site. Yun ang example ng coordinate system, viewpoint, and view site. Coordinate, they are example of coordinate system. Projection on screen. There are two types of projection on a screen. Ang una ay parallel projection. Parallel projection is a kind of projection where the projecting lines emerge parallelly from the polygon surface and then incident parallelly on the plane. In parallel projection, the center of the projection lies at infinity. In three-dimensional geometry, a parallel projection is a projection of an object in three-dimensional space onto a fixed plane known as the projection plane or image plane, where the rays known as lines of sight of projection lines are parallel to each other. It is the basic tool in descriptive geometry. Parallel projection preserve actual dimension and shape of objects. Preserve parallelism. Angles preserve only on faces parallel to the projection plane. Orthography projection is one type of parallel projection. Perspective projection doesn't preserve parallelism, doesn't preserve actual dimension and angles of objects, therefore shapes deform. Popular in art, classic painting, architectural design, and civil engineering. Not commonly used in mechanical engineering. Perspective projection or perspective transformation is a nonlinear project where three-dimensional objects are projected on a picture plane. This has the effect that distant objects appear smaller than nearer objects. Transportation between coordinate system. Model coordinate, word coordinate, viewing coordinates, virtual coordinates, and device coordinates. Model transformation. A model transformation in a model-driven engineering is an automated way of modifying and creating platform-specific model from platform-independent ones. An example use of model transportation is ensuring that a family of models is consistent in a precise sense which the software engineering can define. Viewing transportation. Viewing transportation is the mapping of coordinates of points and lines that form the picture into appropriate coordinates on the viewed display device. Projection transformation. The projection transformation converts the viewing frustum into a cubed shape. The near end of the viewing frustum is smaller than the far end, which has the effect of expanding objects that are near to the camera. This is how perspective is applied to the scene. Translation. Yun ang example ng translation. A translation is a is a translation that occurs when a figure is moved from one location to another location without changing its size, shape, or orientation. In the coordinate plane, we can draw the translation if we know the direction and how far the figure should be moved. Scaling. There are example of scaling. The scaling coordinate system is defined as a map from a real frame coordinates to virtual scaling system coordinates. The selected frame coordinates. The setting is invisible if there is only one frame, are seen as a parameterization of the true geometry in which the physics is solved.
Good morning, sir. The reflection about XOY plane. It will reflect a point in the XY plane over the x-axis. The original point and the reflected image have the same x-coordinate. It will be on the same in the same vertical line. The y-coordinate has equal absolute values and opposite sign. So we just take the y coordinate it's positive, we make it negative. This is the example of reflection about x and y. Then rotation about x axis and CCW by 0. Rotation about the x-axis is the kind of rotation that the object is rotated parallel to the x-axis principal axis, where the z coordinate remains unchanged and the rest of two coordinates x and y only change. This one the example of yung rotation of x-axis, z-axis, and CCW by 0. Rotation about y-axis. Rotation about y-axis. We will ride a bicycle forward. The wheel's rotation about the axis passing through the center of each wheel and perpendicular to the plane of wheel as long as the bicycle does not turn the axis keeps pointing in the same direction. And homogeneous representation. The representation is introduced to express all geometric transformations in the form of matrix multiplication for the convenience of manipulation. Translation open parenthesis x2 y2 is equal to 2 and 1 is equal 1 0 0 0 and 0 1 0 0 then 0 0 1 0 dx dy d equals and 1 close parenthesis and open parenthesis x1 y1 is equal to 1 1 close parenthesis. The coordinate the facilitate multiplication. Homogeneous representation, this one the example of homogeneous representation and scaling rotation. Composition of transformation or concatenation of transformation via multiplication. Here, this one the example of consider a 3D object. The coordinate of their vertices are given as follow. A is equal to 3 5 3 and B is equal to 7 5 3 and C is equal to 7 5 5, D is equal to 3 5 5, E is equal to 3 6 5, F is equal to 3 6 3. Rotate the object 3D by the by 30° and clockwise direction at point D about the y-axis. And meron tayo ditong procedure na first we translate to IT to T translate to T the object at the reference point D to the origin 0, and then we rotate to R about the y-axis. Finally, we translate to T the point D from the origin back to its original position. The definition of point matrix in the homogeneous representation, this one. And mapping and parallel projection. Mapping projection is a method for taking the curved surface of the earth and displaying it on something flat like a computer or a piece of paper. Makers have devised method for taking points of the curved surface of the earth and project them onto a flat surface. And parallel projection is their three-dimensional geometry. A parallel projection or axonometric projection is a projection of an object in three-dimensional space onto a fixed plane known as the project plane or image plane, where the rays known as line of sight of project lines are parallel to each other.
About transformation. Transformation are applied for both changing coordinate system in respect to model coordinate system but also for projection. You can see in the projection the x and y and z axis for three-dimensional figure. Mapping in parallel projection. X sub 2, y sub 2, z sub 2 are assumed to be calculated by applying to transformation matrix T sub 1 to 2 to x sub 1, y sub 1, z sub 1 as a follow. X sub 2, y sub 2, z sub 2, 1 T equal T 1, 2. Mapping and perspective projection. Once mapping has been performed, the CB coordinate not drop yet and the XB, YB coordinates are scaled following the similarity rule of triangle LS needed. Then ZB is dropped. Generating parallel projection. Drop the N. Z sub B coordinate D sub N equal matrix 1 0 0 0 1 0 0 0 0 0 0 0 0 1 matrix UB 0 1 equal D sub N matrix UB N 1. In summary, to project a view of an object on the UV plane of one needed to transform the point of the object by T multiply equal D sub N multiply R Z multiply R sub Y multiply R sub X multiply D OB. Orthographic projection. Projection planes, viewing planes, are perpendicular to the principal axis of the model coordinate system of the model. The projection direction, viewing direction coincides when on the model coordinate axis. There are three predefined view in this figure: top, front, and right. Predefined view in this figure: top, front, and right. Geometric transformation for generating orthographic projection, front view. PB equal matrix 100, 0, 100, 0, 0, 0, 0, 0, 0, 0, 1. Multiply P. Drops Z. The previous slide focus on front view. Now, the focus is the top view. The matrix equation used is with trigonometric functions cosine and sine 90 degree. As you can see in the matrix, the cosine is equal 0. Then sine 90 degree is equal negative 1. And the sine 90 degree and cosine 90 degree is equal 0. Now, we will focus on the right view. Again, we will use matrix equation with trigonometric function cosine and sine 90 degree. Cosine negative 90 degree equals 0. Sine negative 90 degree equals 1. Negative sine negative 90 degree equals 0. Cosine negative 90 degree equals 0. Rotation needed for generating isometric projection. The figure here in the combination of top, front, and right view, also using cosine and sine trigonometric function. Isometric projection equally foreshorten the three main axes. Theta equal positive negative 45 degree. Theta equal positive negative 35.26 degree.